In 2021, I sold out everything. I took a big risk and I just dumped the whole crypto mine, sold every bit of crypto that I had, and decided that I was going to set up a company that was based around engineering with servers.
Welcome to Intersections. Intersections is a podcast where we like to bring together people that have great stories to tell. We're so lucky to have you here in Doha, which is a rare occurrence. I know you hardly actually travel for the past year. You didn't have a passport until very recently.
Well, yeah, I didn't
right?
travel for 15 years.
For 15
a long
years.
time, but yeah,
Wow.
this year it's been 7 or 8 countries.
7 or 8 countries.
Yeah.
No, wow. So it's amazing that you've come to Doha and you're sitting here with us, and go back all the way to the very, very start and lay it out to us.
So I sort of started when I left school as an electrician, and then I did electronic engineering. And my dad was an engineer, that kind of thing. So it sort of goes back generations, that kind of thing. I worked in mechanical engineering then for 17 years for a company that makes wagon parts and hydraulics and stuff. So sort of my journey into IT is quite an interesting one in that, because when I set Sytronix up, what I wanted to do was transition into a place where I'm using all the skills that I built up in all these different areas of engineering. Yeah, so like hydraulics, it would be used in the cooling systems on computers. I worked at a sheet metal company at one point which made trailers, but that sheet metal knowledge helped me to design chassis. I worked for a PCB manufacturer many years ago, and they were just making timing circuits for things, but that gave me an introduction into making PCBs, and I just wanted to pull all those skills together from all the different areas of engineering that I'd work in. And when I thought about it, I mean, when I left the engineering company that I was working for, that I worked for 17 years, I became a crypto miner, and I was doing that from about 2015 through to 2021. And that's kind of how I got the money to set up.
So how did that transition happen? Like, how did you? What was the exit? What brought you into crypto?
It's a complicated one. I lost money in a bank during the financial crisis, so I got interested in different monetary systems and things like that. And crypto was sort of a logical step. And I think crypto's changed since then. It's not that. I was a little bit more ideological when I was younger. I always enjoyed working with computers. When I was a kid, I sort of had a Commodore 64, and I used to type in programs to make computer games when I was a kid and stuff. So, but in 2021, I sold out everything. I took a big risk and I just dumped the whole crypto mine, sold every bit of crypto that I had, and decided that I was going to set up a company that was based around engineering with servers. And I wanted to build the best server company. The first 3 years of Sytronix was just design. We kind of didn't do a lot of sales. It was just designing chassis, designing some of the components that we needed within the servers, traveling around, meeting different people around the UK, gathering an engineering team together. It's sort of, I suppose it's just snowballed, and I don't really see myself as a businessman. I see myself as somebody who just loves engineering. So every day I come in, I love what I'm doing, because one day I'm working with a company that makes batteries, the next day I'm working with companies that do simulations for aerodynamics. And the other week I was at Manchester University, and there was people there making detectors for telescopes, and it's just being a bit of a nerd. You kind of you just love seeing all these different things that people are creating. And that's one of the great things about Utopia as well with you guys, is the fact that you're helping build that ecosystem with different tech companies. And when we get our customers contacting us, many of them are tech startups. So that's where the synergy with you guys works, because you guys are sort of funding projects like that. You're pulling that together. We were sort of building up the technology to help those companies, but at the same time realizing that those companies also need business help. And that's where you guys came into it.
When we talk about hardware, you sometimes think it's just a rack, but actually the applications from renewables, from kind of going into network connections, being able to rent out your gaming PC into quantum. Talk through us the spectrum of work that you service.
Yeah, so at the moment we're currently working on a couple of different projects that are surrounding AMD hardware, where we're trying to create an automated way of tuning servers so that they use less power. That's one of the main projects that we're working on, and we're also working on 3 different chassis that we design. We're working with a company called Superdielectrics, which Alexandra, who works with you guys, introduced us to. And they're producing a zinc bromide battery. And that's quite an interesting project because we found that insurance companies didn't want to insure lithium-ion batteries directly in racks because of the thermal runaway problem. So they're developing a type of battery that can deliver just as much power in a short period of time, but it's much safer. You can heat this battery up to like 250 degrees centigrade and the thing just melts rather than explodes and burns the data center down. So that was sort of one of the projects that we started.
What's the thermal runaway problem?
So lithium's one of these things where if you get water on it, it can set on fire. If you heat it over a certain temperature, the thing can just burst into flames. And obviously this is one of the things that data centers are really worried about. I mean, if you have a fire in a data center, it can cost millions of pounds to repair. And traditionally they've used lead acid batteries, but if you go to many jurisdictions around the world, if they melt, you get in sulfuric acid and lead in the ground, and there's massive fines for poisoning things and stuff. So insurance companies need a way around those kind of problems with much safer technologies. So zinc bromide can be toxic, but at the same time it's far less toxic than sulfuric acid and lead, and it's far less dangerous than lithium ion. So we're looking at those kind of technologies, and we're doing a proof of concept with them where we basically build an enclosure to put the battery in, and then we operate servers on it, deliberately cut the power to systems to check that it can deliver the power to the servers, and just help them with R&D.
And for anyone listening who doesn't understand what a data center is, what a rack is, how this design and where a battery fits into that, a lot of people, when we're working with them, they hear about the cloud and they don't necessarily understand the underlying hardware that enables all of it.
I think, data center is a nebulous term, really. So, I mean, there's different types of data centers. So you've got AI factories, which are specifically around high-performance hardware that works for artificial intelligence. You've got HPC data centers for high-performance compute, and they're doing things like simulations for engineering. So they might be doing like oil exploration or weather forecasting or aerodynamic simulations on an aeroplane wing. And an AI factory and a HPC factory are pretty similar in the way that they're actually laid out. They consume a lot of power, they need a lot of cooling and fast internet connections and things like that. And then you've got hosting type data centers, and they're sort of dealing with websites, email servers, and generally Sytronix deals with the HPC, the AI, and the rendering side of things, So that's like CGI rendering for films, computer games. So like when you see cutscenes in games and stuff like that, and so I'm not going to mention the films, but we've worked on some hardware that's been in some pretty famous films that the vast majority of your viewers will have seen at some point,
When customers come to you and clients come to you from computer games to F1, or even co-located with renewables, like, where do you see people getting it wrong when they're coming to rack design and designing for hardware at the moment?
So I think the thing is about it, is that there's different schools of thought. You can go to some of the bigger IT hardware providers, and they just want to sell the hardware, deal with it from that point of view, and obviously recommend something that's relatively suitable to that. But generally, it's about the sale of the hardware. Myself, I see myself as a bit more of a nerd than that. I love getting involved. I love looking at how that technology works. And when it comes down to sort of CGI rendering, many years ago I used to be big into sort of computer gaming and stuff like that, and I love things like Star Wars and stuff like that. So like getting the chance to work on films like that and look at, meet the game designers and stuff like that, and look at the art. You just some of that stuff. It's not in my realm of knowledge, but it fascinates me, and I just love looking at that kind of stuff and thinking, you guys have been really creative. So I kind of love helping people along with those kind of journeys that they're on. And so as a general rule, when we start a sales process, we try to sit down, understand what the customer's trying to achieve. Get to know what their goals are and how those goals are going to pan out in the future, and then basically then get to the point where we're going to recommend what type of hardware they should use, what kind of infrastructure they should use. And sometimes it comes down to budgets, sometimes it comes down to the size of the company and the size of the project. So there's a wide variety of different things.
Could you maybe give us a primer on how you design the hardware systems? Everyone thinks about chips, right? Could you just lay it out in terms of the chips, the networking, the memory, the combination of that, and how that has an impact on performance?
Yeah, so we look at things as a full stack solution from a start, yeah, because when you're building out a data center, you're not just really thinking about just the hardware itself. So and it's different in every jurisdiction. If you go to Norway where it's really cold, they've got very cheap electricity, just like they do here in Qatar, but it's freezing cold there, so they don't need to worry about the cooling. Yeah, but if you tried to build a data center the same as you do in Norway, here in Qatar, the whole thing would overheat and it would cook itself. Yeah, so you first get a feel as to what the local conditions are and how that's going to affect what they're actually trying to do. You look at things like electricity cost. So in the UK, electricity is some of the most expensive in the world. So you really want to be working around performance per watt. Yeah. And we sort of adjust the way that we design based upon what they're doing. So we'll design a custom-based server for a specific customer. So like if we were designing here, we'd work with partners and we'd put phase change cooling into the system, and we try to create something that's energy efficient, cools extremely well and doesn't deal with the sort of conditions there, and also look at what the people who are using that hardware do. So for example, you're dealing with a lot of artificial intelligence here, so we're looking at graphics cards and things like that. You really have to understand the problems that each individual customer faces and then try to come up with a solution for that. And I think building bespoke servers around that is one of the sort of key successes to what we've had with Sytronix, because we actually care about what they're doing, and we will actually set CAD designers designing a completely new chassis, designing a new power distribution board for it, and various different things like that.
And how do you think about model design, so model evolution? So, some of the earlier AI models were incredibly hungry in terms of hardware usage. As the models compress, which essentially for our listeners makes them more efficient, how do you think about building the hardware but always casting an eye forwards in terms of where the usage demand's going to be?
Well, I mean, that's the thing. I mean, if you look at training, for example, people are going to be buying things like NVIDIA B300s or AMD sort of MI350Xs and upwards on those kinds of systems. But the vast majority of hardware that's actually needed really is for inferencing. So the hardware is different for that, and so long as like people are getting answers from the AI that they need, whether it's a picture if you're using DALL-E or you're getting an answer back from like ChatGPT or whatever, people are bothered about how long it takes for that answer to come back to them. But it's fine so long as it arrives within a few seconds. No, you could go out and buy a ridiculously expensive hardware and get an answer in milliseconds. But in reality, when people are using an AI, they're not all that bothered about it arriving in like milliseconds. They might just want that answer in 5 seconds, especially if it's far cheaper for them to get it in 5 seconds than it is to get it in a millisecond. But obviously, if someone's sat there waiting for half an hour and they're twiddling their fingers over it, then it becomes a problem. So when we designed the architecture around our main server, we designed it in a modular way so that you can add more and more graphics cards, and you can add things called PLX switches, which allow you to run more PCIe lanes on there. Now, PCIe lanes are what you hook different devices up, so you can hook network cards up to the system, graphics cards, things like that. So we designed the server to be modular so that it can scale from one graphics card right up to 32 graphics cards. And that allows the customer to have an upgrade route. And we always try to put the fastest CPUs on there as well, so that when graphics cards start to get old, they can sell the graphics cards off, they can put new graphics cards in the system and still carry on running without having to do a full upgrade on the system. And that saves customers a massive amount of money. It improves the return on investment, and that's what it's all about when you're running a data center. And I suppose it's different for different people. If you're an AI developer, you might just want things doing quickly. But if you're a data center operator, you want to make money. So we have to think about all these different aspects of how it's run.
We see the importance of this exactly, in terms of having our companies be model agnostic and as far as possible be open source, and we want to create these kind of sovereign, accessible as well as sustainable environments where they can run in. And that's why we've designed with you our very own hardware system. Could you tell us or explain a little bit more about the spec of what we're actually going to have in the office here?
Yeah, so we designed the system where you've got a network on the system, so you can hook up more systems as you scale. At the same time, we have a separate orchestration node, and the orchestration node can deal with the main server, split that main server up into many different components, so you can run more than one user on a graphics card, or you can give the whole system to one person, and you can do it in a virtualized environment, you can do it in a Docker environment, you can do it as a bare metal machine. So the ability to sort of chop and change, and the host node is the main sort of machine that orchestrates all that. And we at Sytronix, if you need tech support, we can sort of connect to that host node remotely. We can do work on that without affecting what your end customers are doing. So we're not slowing your customers down that are actually using the hardware. And it also gives you the ability to scale. So rather than having to go through a whole process of setting up another server and all the rest of it, we just deliver a server that's built, and then we can use the orchestration node to just dump more data over to the new server and set that server up for us. And it allows us to do this stuff kind of remotely. And obviously we can do that from the UK just straight through the internet, and that allows you guys to scale up and down very quickly and adjust the way that the hardware works.
Could you explain to people what's actually happening under the hood of some of these neoclouds that we see out there in terms of what they're doing with orchestration, with different ways of management of containers and such?
Yeah, so there's lots of different ways of operating a computer. Yeah, so if you've got a basic PC, yeah, you're just operating with a relatively small core count CPU and a graphics card, and you can play computer games on it, and you can do all those kinds of things. But if you're dealing with a server, let's say you've got 8 graphics cards in a server, and you've got many more CPU cores. What you can do is you can split the CPU cores up. So you could say you've got 128 cores on the system, you could split that into 8 16-core machines. You can pass a graphics card through to each one, and it'll act like 8 PCs or 8 workstations. Or you can split it up using secure Dockers, and Dockers are like a secure container. So you're still running the machine as one machine, but you can split off a piece of hardware and just use that in a secure environment. Whereas a virtualized environment is different in the fact that you would run a separate operating system on each one. So you could have Ubuntu on one virtual machine, you could have Windows on another virtual machine, and so on and so forth, yeah, and you can split up the machine. The whole process of divvying up the machine is called orchestration. And that ability to chop and change about how the hardware works, the performance of the individual components and stuff, means that a customer who only needs a small amount of power because all they're doing is running a basic database and a website, yeah, you can give them just a few cores and a little bit of hard drive space. But you could have an AI customer on there who's really, really hammering the system hard, and you can give him the other 7 cards on the system. And that ability to chop and change about is like something that's quite critical to the way that data center infrastructure works, and something we spend a huge amount of time on in the software side of things, because it helps us with the sales. So we don't just build the hardware, we're looking at how it's orchestrated, how it's monitored. So we have monitoring software in there where we look at things like the temperatures on the GPUs and temperatures on the CPUs, how much RAM is being utilised, and various other things like that. And we can all monitor that without interfering with what the customer's doing, especially if you're in a secure environment as well, because we can have it where there's a situation where the customer completely locks us out of a VM. We can't see what's going on, but we can still see critical data like what temperature the GPU is running at, or what temperature a CPU is running at. We can see if the machine's crashed, it's actually halted and stuff like that.
And maybe a bit of a sales pitch for you guys, but where are other providers getting it wrong here? Is it excess capacity, underutilization, the inability to orchestrate? When we went into some of the software that get provisioned on top of hardware that can be at astronomical costs. You might think you've just bought some hardware, but you don't even know what needs to then live on top of that hardware to be able to run it.
I think mainly it's like I said before, it's about understanding what the customers need, and only building what people actually need, If you see, I could just say, just buy this really expensive machine and it'll do everything, but then that machine might only be 10% utilised, and the customer's effectively sat there going, I've paid for 10% of what I've got, but I've got another 90% on top of that, and I'm still paying for it, and it's still consuming power, and so as a general rule, we tend to build what people need, and that again comes back to understanding what the customer's trying to achieve, but understanding all those different workloads is something that's one of the more difficult tasks that I have to deal with. I spend like 4 hours a day reading, and I'm an absolute YouTube addict at watching like videos on how different people do different things.
Is there a way of quantifying load? Is it based on users?
We have lots of different types of hardware in our own little research and development data center. So we've got 4 racks, and we've got like 30 machines in there. And we can split those machines up in different ways, and what we'll do is let the customer have a trial on that. And they'll say, yeah, that's brilliant, or we don't need that much, or we want something that's quicker than that. And then what we'll do is we'll let them test. We'll let them test for a few days, and then once they've come back and they're happy, then we'll then build a machine that's specifically around what their needs are. And that's very different than the way a lot of other hardware companies work. They won't let you do a POC. And obviously Sytronix does need to make a profit, but at the same time, having that love of helping people out and that care for what the customers want is like a big driving factor behind myself.
Ethos and culture is a very important part of making sure that a company is successful, and setting that right ethos, the right behaviors, the right incentives around the humans, around people. And your team speaks so highly of you. Jason and Alex, which a shout out to them as well. So could you share a little bit of those behaviors that you've put in place?
Yeah. So firstly, I'd say that I'm friends with all my staff. They say you should keep distance from your staff. And there is always a little bit of distance when you're a CEO, but the biggest thing that we do is just we all collaborate. We all sit there and we all put ideas forward, and we'll write down why are we developing this product, what's it for, and what problems is it going to solve, what's the current situation around the technology that we're currently developing. Do we already have something that does this? And we'll ask these questions, and everybody's involved in it, from sales, because obviously the sales guys, they're speaking to customers on a daily basis, so they know what the customers want. But the engineers need to know what the customers want as well. I try and encourage everybody to have the dinner together. We'll all sit around, we'll eat food together, and we'll thrash out the various different problems that we have as a company, and that has built up a really good collaborative thing, because we all love what we're doing, and that we're all driven to that same goal. And it's like, right, okay, you guys learn from each other, Not just learn from me, learn from each other, And I try to learn from my staff as well, because you can become very tone deaf as a boss if your staff don't feel like they can approach you with a problem. If you don't know what the problems are within your own business, then you're not going to solve problems. So we try really hard to listen to my staff and actually listen to them, not just in one ear and out the other. And that's been one of the real key successes of Sytronix, is how we all collaborate with each other, and the fact that there's a very friendly environment, so people are all on board with what we're doing, and we're driven.
And it really comes across. I mean, you guys are not just great technology, but great to hang out with. Like, I think we spent about an hour yesterday just nerding out on chips, the business model on top of chips, different applications into geothermal power data centers. I mean, then we fall into these rabbit holes together, and then we find opportunities, and it's just been a pleasure the last few days.
Yeah, well, it's like nerds chatting together, isn't it? I mean, if you can have a good nerd off, it's brilliant. We all love that kind of thing.
I think partnerships have been a big ethos of us. Do you think there's any other partner that we could potentially work with that you think deserves a shout out?
Oh, well, there's loads of companies. I mean, obviously we shouted out Seabuller Electrics earlier, but we're working with Spinor, which is a spin-off company from Manchester University that's working on quantum computing. We signed an MOU with those recently, and they're effectively building a quantum computer. They want to commercialise that into the data centre environment, so we're working with them. They've developed a new type of quantum computer that works at a slightly higher temperature, so it requires less cooling equipment and stuff. So we kind of love getting involved in those sort of meaty projects like that. And there's other projects with different companies, and unfortunately I can talk about the details of it, but what I can't do is mention certain names and talk about certain things, because the problem is with it is we're NDA'd up to the eyeballs by loads of different
So
companies.
we have a lot of entrepreneurs that are just starting their journey. Given that you've been successful now in terms of building Sytronix up, making it revenue generating, creating a great culture around it, what would be some of your advice to the entrepreneurs that are working with us?
Oh, never give up. Never give up, yeah. If you've got an idea, follow through with your dreams, yeah, because if you don't, you'll kick yourself when you get older, yeah. It's very easy to just get stuck in that rut of doing a 9 to 5 and never really thinking past earning your next wage, yeah. But I think human beings are just in that much better place when the mind is allowed to be creative and they have that freedom to love what they're doing, yeah. And if you love something and you really, really, really want to do it, do it. Don't just sit on your ass and pretend that it's, it'll just land on your lap, yeah. You have to actually go out and grab life and for me, that's one of my driving factors behind it. I'd hate it if I couldn't go out and do these kinds of things on a daily basis, dealing with different companies in technology, because it makes my life so interesting. I never know what's coming the next day. Yeah, I don't know if I'm going to be dealing with a company that deals with batteries or aerodynamics, or a biomedical science company that's working on cures for cancer, or just an AI company that's dealing with making computer games.
Yeah.
And you never know what's going to happen on each day. Like every time I pick up my phone, it's like, what's it going to be next? You want that in your life, yeah. You want that in your life. Trust me, this is the best thing in the world, yeah. So follow your dreams, yeah.
Wonderful.
Lovely.
Wonderful.
I think one last request is that we ask every guest that we have to propose a question that we ask the next guest that actually comes on. Do you have a critical question that you ask people that we could maybe pass on?
I would say, what's your dream for the next 5 years?
What's your dream for the next 5
Yeah,
years?
what's your dream for the next 5 years? And not just about business. What's your dream in life? Yeah,
Your dream in life. Yeah.
because if you follow your dream in life, if your business follows it, you'll love it and you'll be driven by it. Yeah.
Lovely.
Beautiful.
Yeah.
Well, thank you so much, James. It's
Thank you.
been a
It's
pleasure.
It has
We've
been a
had so
pleasure.
much
To
fun.
have you here.
The rabbit holes we've fallen
Yeah.
down, it's been good.
I mean, it's like when I come here and see what you guys, I think birds of a feather. We're in the same game. Yeah, we're passionate about what we do. We're passionate about helping young people set up businesses. We're passionate about people driving things forward, and that's one of the things I love about working with you guys.